Good morning. Sound check. 1, 2, 3. This is Dan on the train barreling down the tracks towards the station. Let me know in the chat if the sound levels seem good and you can hear me and the music just fine. All right. Good morning. Happy Thursday on the coding train. Oh, deep breath in with me, your host, Dan. All aboard. Good morning. I think today is going to go just fine and dandy and really well because we will be beginning, as usual, with the ceremonial reading of the random numbers. Now, today is February 20th, 2020. That is a lot of 2s and some 0s. So let's find our way to page 20, 15, 16, 17, 19, 20 in our book of random numbers. And perhaps we will go down to the 20th row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm sorry, did you think you were watching coding tutorials? 15, 5, 10, 15, 16, 17, 18, 19, 20. All right. And today's numbers on the coding train are 5, 10, 15, 88,235, 40,413, 22,041, 82,638, 31,923, 87,851, 60,190, 98,420, 83,623, and 22,256. I can't hear anything, says Offbeat Stuff. I'm assuming that Offbeat is a little offbeat today, and that only Offbeat is not able to hear what I'm saying. I'm out of breath, strangely. I'm very, 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 very tired this morning. It's morning for me. It's about 9:30 a.m. This is my second live stream of this week. And if I'm being honest, I really shouldn't be here today because I have this personal commitment, personal goal to be working on the Nature of Code book, second edition, in JavaScript. And I have been working on edits of this book. And I am all the way through chapter 4. I am now working on chapter 4 edits, which I started over the summer. And I've had this file open on my computer since I last live streamed on Monday, really since Tuesday afternoon. And I have this file open. and I keep trying to get to editing it, and I haven't had any time. So what would not be a better time than the 2.5 hours I happen to have free this morning to live stream? So I really, really need to carve out the time to work on this. And I know there's a crazy solution that some of you have suggested, which is why don't you just work on it during the live stream, which is an excellent idea and one that I hope that I will do at some point in the future. But here I am. I am committed to 4 live streams per month. And here is my second, I think in February. And so I'm going to do, and I'm in the videos that I'm making that go along with this book, I'm way behind chapter 4. And today I'll be doing videos about chapter 2. So all in all, there's a lot to do, and I am going to try to get to it. And the reason why I brought up the number 4 there is I think in light of this squeezing out of the time to do all the things, I think I'm going to move to, at least for February, March, and April, 3 live streams per month, with hopefully that carving out a little extra time to work on the Nature of Code book, as well as my love, my true love, which is to code in the cabana. Oh, cabana, there was a day a few weeks ago where I sat there and it was snowing out and the freezing cold was frosting on my mustachio, and I was looking at the Hilbert curve pattern and typing away and making this beautiful visualization. It was so satisfying and relaxing. And then all the people of the internet came and they watched the video and they traveled in their minds to the cabana. And there they were, making their own versions of the Hilbert curve. So many beautiful variations and artistic projects, which I showed on last live stream, and I would really like to do more of this. So here's my goal now. I am setting this out into the universe through my lips to your ears and your reading of the captions. My goal is to do, I might not hit it. People don't make their goals. That happens, especially people on the internet making content. 3 live streams. This is my second for this month, so the third for this month will be next week. And 1 cabana video. So I suppose this one will count for February, and I want to do the next one for March. Now, the topic I actually want to do for the next cabana video is marching squares. Oh, and there's a wonderful video from, there's basically, if there's 2 YouTube channels that I think I refer to the most in terms of the content that I'm doing. One is Sebastian Legs, which is right up here. Is it lag? I've gone over this so many times with Sebastian in my mind, practiced it, and then when it comes down to the moment of saying Sebastian's name, I forget. But and then the 3 blue, 1 brown videos, which I used to form a basis of the Hilbert curve video. And I really want to do marching squares. Yeah, Jason G is saying it's a Romanized version. Funny, I look at the chat and people are discussing what the word cabana is, which I guess cabana would be the authentic pronunciation for the Catalan Spanish word. A small wooden house. I mean, it's really a shed. A shed is a more accurate term, but and I read that as romanticized because I'm romanticizing the garden shed into a cabana. But David, I know David is watching, and David is the volunteer maintainer of the wheel. The wheel is sort of this nebulous thing that I aspire to have as like a really functional aspect of the coding train. The wheel, I guess there's some kind of link here, the wheel of the train itself, where I like to sometimes I can't pick what I'm going to do. So I spin a wheel and it tells me what to do with a bunch of options. So I haven't really figured out the way to fully embrace the wheel on the coding train. But I use it from time to time. And maybe, I don't know if it's ready or available. I did spin it last time to pick the Hilbert curve. It actually landed on Z curve or Z function, I don't remember. Which I then, doing some research, decided that the Hilbert curve was an appropriate analog for that spot. So I would like to spin the wheel again maybe for the next Cabana topic today, if I can sort of like get that up and sort of figure out what's going to go on there. But the topic, before I get into the topic, I want to address a comment in the chat. Fabrice writes, I stole your code about the Fourier series. So I want us to try, as a community, to get away from the term, I stole this code to do this. Now, there is something which would be, stealing is a thing, and people can steal objects and all sorts of other types of things, and I think the word steal with code is probably appropriate in some contexts. But I think we use it, I'm saying people that I hear, me, myself, and other people that I hear talk about this, overuse it to really mean something much more positive, which is, I made something based on your code. Thank you for releasing your code in an open source way with a proper license that allows me to make this creative project and then give you credit back. So there is no stealing of the code. The code, from my examples, its exact intention is for you to reuse it. And I actually released them, those code examples are released under the MIT license, which does not require you to credit back. So you're under no obligation to. And me personally, feels weird for me to say, please credit me, because I don't feel like I want to say that or feel a need for that. But in my own work and practice, it feels very important to me that I credit any code that I'm using from somebody else. And so I try to overdo it. And I'm sure I make mistakes, and I'm sure I've written code that that's sort of copied and pasted from somewhere, and I didn't think it through carefully enough, and I'm miscrediting it or whatever. So I welcome feedback and people to help point out where I can do a better job at that. But that's something that I feel like is very important. Okay. Delta X Delta Y says factorials stole from multiplication, which stole from addition. And Simon is linking me to the to-do list. The to-do list, issue number 1904. Coding train, website, issues 1904. 1904, what's something that happened in 1904? Great, so I could use this as my spin the wheel. Yeah, or at least I could pull something. So many things to make video tutorials on. One thing that thank you for maintaining this, by the way, Gypsy Dangerous and Simon Tiger. This is so helpful and awesome. I want to talk about what I'm doing today, but there's something else just popped into my head here. Yes, announcement. Remember how I said 3 live streams per month? This is my second. Next one would be next week. There'll be 2 next week, actually, because, every commitment I make is a somewhat loose commitment. Things go wrong in scheduling-wise a lot for me. I have some things, family and this full-time salary paid job here at NYU that do really require me to be in certain places at very precise times. And for better or worse, the YouTube stuff I can be a little fungible about, if that's the right term. But I want to mention that Coding Garden, which you might know the Coding Garden from its raids on the coding train. Coding Garden with CJ is a YouTube channel which is, I like to mention it whenever possible because it is an excellent complement to the coding train. In particular, if you're looking for full stack web development. Most of my stuff is a little goofy. Math algorithms, visualizations, very informal coding. Maybe some computer science topics which have a sort of formality to them. But Coding Garden with CJ is, if you're looking for some professional development, and there's plenty more to it than that, but it's a nice complement to the stuff that I'm doing. And CJ and I are planning a collaboration next week, next Wednesday, I believe, February 26th, to look at how to program a Discord bot. So I think the idea, CJ can correct me if I'm wrong. Coding Garden is watching. Okay, great. So here, I'm talking about this now. I think this is the way I'm thinking about it, and CJ's in the chat, so maybe CJ can offer his point of view. The way that I'm thinking about this is I know nothing about Discord bots. other than my sort of like loose sense of what they are and how they work, knowing how to program other kinds of bots. And so I'm going to go on the coding garden, and CJ will maybe teach me a little bit about how to program a Discord bot, and we'll tinker around and make something. And then that will lend itself to me returning back to the coding train to maybe do a set of tutorials about how to make a Discord bot. That's kind of my idea. Okay, so that's on the horizon next week. Another thought appeared in my head while I was talking about this thought, which I wanted to mention, but I can't pull it out of my brain right now. I suppose it'll come back to me. Alrighty then. So, what is happening today? Let's see. Give me a little moment to feel the way to. In a moment. Looking for something. I am working on something that I need to find before I go a little crazy. I am going crazy. All right. In progress. You might be aware that YouTube has a new feature called a learning playlist. My ML5JS videos are in a learning playlist. My intro to programming with P5JS are in a learning playlist. The GitHub videos are in a learning playlist. I am now attempting to put together, please go to Pikachu. Oh, if only you knew how much I love the Pokemon. I don't want to admit it. Let's see if anybody can guess what this is. Sitting here on the desk. Okay, back to important things. It's okay to love Pokemon at my age, and especially if I have children who also love the Pokemon, and I'm bonding with them through the Pokemon. But I'm not getting them their own phone. They are not old enough for their own phone and their own app. They do not need it. What's the expression? Wait till 8, not 8 years old, 8th grade. I'm putting this out there. All right, you don't need to be involved with this kind of decision-making, parental decision-making. I have younger viewers to the Coding Train. Not right now, because you're in school. But maybe you're like in Europe or something, or India or some other part of the world where it's evening time and you're not in school and you are watching. I need some help. This parenting thing is very hard. Okay, wait, back to this. Oh, it's getting warm in here. Woo! Oh, la la. Got to catch them all, yes. I am working on a new, this would happen a lot faster if I didn't just go off on all these tangents. Pokemon-based algorithm learning. Arnav says I am in 8th grade. So Arnav, you are, perhaps at the appropriate, do you have your own phone? I'd like to know. Okay. Yes, a bunch of people are saying they're in India. I just picked Europe and India arbitrarily. Incidentally, if you're curious, I haven't checked this recently, but the last time I checked, US was in terms of viewership, and I don't mean the live viewership, I just mean the overall viewership across everything. US is the first country listed. Germany is often the second, which I find interesting, and India has been quite consistently recently in the 3rd spot. So thank you, India, for if you can thank a country. All right. Arnav says, yes, I have my own phone. If it were up to me, says Zero, I would ban smartphones from kids till they were 16. Offbeat Stuff says I am in 10th grade. Flip phone? What about a flip phone? Argentina here. I love, by the way, when everybody in the chat, and Mr. Mugami says I'm in 8th grade too. Mike says I didn't have my own cell phone until I was 30. Guess what? Me too. I'm trying to think, when did I have? I had some of those really old, early Nokia phones. When would I have had those? Early 2000s, I think. Okay. My parents got me a cell phone at 13 and smartphone at 16. Okay, good. See, everybody has very reasonable parents out there. I'm glad. Okay, I gotta get back to this. I'm on a ticking clock here, everybody, and Dane says I'm from Germany. Samsung Z Flip. But the chat is really fun to read. I have to stop myself here and there because it becomes Peru and Brazil and hello. Okay, not looking at the chat. Looking at you. We are here together. I'm not looking over here because when I look over here at my monitor, I also see the chat. That's my monitor. It's not my monitor here, it's over there. If I look out of the corner of my eye, a little behind the scenes here. Want to see? So this is the way it works. Oh, it's flipped. That's the camera, and this is me. And then over here is where I see like this monitor on the wall that has all the chat and all that sort of stuff. Okay. Oh, it's still there. Soundboard is here. You can't really see it. Okay. 200 people watching, and everyone is chatting. Yes, I am in the Discord chat, David Snyder. I'm in live chat. I see people saying in the live chat what age they got a cell phone at. It's very useful for me, these live streams where I can just ask questions, and I get a wide survey of people in fans of the coding train. Not that you're all fans. Some of you might be spite watching. Is that a thing? Okay. This is my project for these 3 months. I would say I hope to have this completed by the end of May. This is what it looks like in progress, and all these videos are unlisted and still being finalized. If you want to join as a member of the coding train, you will get a little bit of early access to this stuff, but ultimately it's going to be out within a few days of sharing it with the members. But it's helpful for me sometimes to share videos with a smaller group to make sure there isn't like a major issue. So that's on the horizon. One of the things that's interesting about this, and let me see if I can get over here, is that don't play the video. Is that there are a lot of older videos that will be in this playlist. So I'm trying. Some of these I'm remaking and putting like interstitials in, and then others are just videos that I made from before. Where I am currently is there are 3 P5 vector tutorials ready to go. They need maybe some like minor edits, and then we'll get uploaded and released. I've recorded more of them on Monday when I did my last live stream. Those are currently being edited. Thank you to Mathieu, who's in the editing car of the train. It's like next to the cafe car. You know what my favorite car is? The quiet car. Oh, how I love the quiet car. And today, close this, I am going to start going over the making new video tutorials to go along with Chapter 2, Forces. So this is the topic for today. I don't expect to get too far with this. It would be awesome if somehow, like by the end of today, by the end I mean around noon, so about 2 hours from now, I somehow got through all the examples in this chapter. But if I'm looking back on how things generally go on the coding train, I'll be glad if I sort of get somewhere with 20 minutes of usable content into that learning playlist. So if you haven't watched before, I'm really full all in on this thing now, at least in this time, where the live streams are raw, unedited process video, essentially a process session of me attempting to put together stuff that will go into the edited videos. So you can really just turn this off and go do something else. So many things in life that you could do. I'm trying to think of what a suggestion could be. You can make yourself a nice cup of tea and read a book. You could do some exercise. You could call a friend, somebody you haven't been in touch with in a long time that you feel like you really, you miss them. Call them, text them, message them, go visit them. And then if none of those options seem good, I guess, you can be here with me in this sort of like nonsense. Because ultimately, the point of this is to then take this material and put it into a format that students might watch in the context of some kind of curriculum. 30 minutes of usable footage and an hour and a half of rambling is truer words have never been spoken. Kay Weekman says spike watching. I meant spite watching. Hopefully nobody has spite. I don't know. I was going to say a different word, and that sounded sort of very mean-spirited. But spike watching, processing. All right, everyone. But I think I can get going here. Let me get myself organized. Oh, let me also give a quick shout out to the sponsor of today's Coding Train live session, Brilliant.org. I looked at the homepage of Brilliant.org right before I started, and there's a puzzle challenge. The daily challenge is so great and so exactly aligned with a coding challenge I previously did. So after I get through about half an hour, 45 minutes of some tutorial stuff, I'm going to come back and look at that challenge. But if you're interested in learning more about Brilliant.org, which to me is one of my favorite websites to learn and discover and expand my brain and find topics, more information about topics I'm interested in, interactive lessons, you can go to brilliant.org/codingtrain, sign up for free. There's lots of stuff you can do for free on the website that I really enjoy. I have 2 accounts, a paid one and a free one, because I'm always curious. So actually, I'm quite surprised with how much you can do with the free account. But then if you want to unlock all of the courses and you go through that link, you'll get a 20% discount. At least the first 200 people who use that code will get a 20% discount. Okay. Thank you to Brilliant for the sponsorship. I'm so grateful and happy for this opportunity. Okay. Ashish writes, why are you not coding? Oh boy. I hate to tell you this. Ashish. I got nothing. I got no answer. All right. Spear says, great work. As ever, I'm preparing a workshop on making music from neat algorithms tomorrow with your soothing voice in the background. All right, I got to know more about this. I'm curious. By the way, nobody, time out, get into the tutorials. Ashish, I hear you. Ashish, I'm getting there. It's been a while. There was in the early days of the coding train, there was this swell of energy around the internet for people making weird mashups of my voice and music. And I just love them. And there's this crazy one with
unicorns and rainbows and cupcakes. What else?
That one. There's the
as always, I always
the well-known, if I may say so myself, this dot song. There's the Pearl and Noise.
This is random. This is
song
noise.
by
Pearl
F.
and noise,
Looper.
that is.
There's Polar to Cartesian. I love. But no one's made one of these in quite some time. Am I just not inspiring the youth of today to go out and make their tunes? Are you all just too busy on TikTok now? Please, maybe I could offer you a little something, a little Coding Train t-shirt. I don't know. I miss those tunes and I need some new ones. If you want to find all of them, by the way, it was Christian Peterson, SoundCloud, Coding Train, where there's a whole playlist of them. Yeah, Daniel Schiffman, Coding Train remixes.
So this is random. This is noise. Pearl and noise.
And actually, every time I go here, I'm reminded that there are more that I don't know about. So, and I haven't. Where's Espen Larsen these days? I love this refactor song. This one, I'm done. No, that's it. Yeah. That's that one. Bitcoin Millionaire. I'm a little afraid to press play on this one.
Hello, I'm here. I am here mostly to apologize. Please stop. Don't throw the tomato. There's the green wall. We'll have the tomato fly.
I know you can't really hear this. Sorry, it's when I play some on my laptop, it doesn't go out through the audio. Yolaxi has made a bunch, so the loading song.
There was an error. The song didn't load. And then there's a callback that's it's loading, it's the loading song. It's loading, it's the loading song. So let's see if this works now. It's loading, it's the loading song. It's loading, it's the loading song.
Okay, so scratch that. There's a bunch here that I have yet that I gotta download and get going here that I can play. And Arnav writes the refactor song is my ringtone. That's pretty amazing. Okay. All right. Remember I was getting myself ready? Oh, I remember the other thing I wanted to talk about now. It came back to me. Yeah, this is where I left off. Okay, great. I remembered the other thing I wanted to mention, which was Processing Foundation fellowships. So the three main components of my sort of work life these days are the coding train, which is what you're watching right now, ITP and IMA, which are two undergraduate and graduate program at New York University, Tisch School of the Arts, where I teach. And then also the Processing Foundation. The Processing Foundation is a nonprofit. It maintains the coding platforms, Processing P5, Processing.py, and some other related tools. We have a mission around empowering people of all interests and backgrounds to learn to program, and a lot of other types of initiatives that go along with that mission, and one of which is the fellowship program. And the 2020 fellowships were recently announced. So I don't think did I go through these already on Monday? I might have, but let me briefly just mention them because some of the projects might interest you and you might like to follow them more closely. Aaron, I think I have like a weird deja vu that I was going through this actually live. So somebody stop me if I was. Strange coming from someone with a name called Offbeat complaining about how I go off topic, but it is true. Aaron Davey is going to start a Cozy Coding, which is a series of weekly Twitch streams. I think you're going to be interested in that. If you're watching this, you're definitely going to be interested in that. I'm going to be working with Aaron on this. Abdullah is working on a teaching code and language to children and education in southern Morocco. Michael O'Donnell is working on P5JS activities for children 8 to 12. George is working on OpenCV library with processing, and Kalila is working on accessibility and text and visuals related to the Americans with Disability Act. And Inwa and Sunghyun, they are working on P5JS in Korea. And there's a lot more specifics. I just gave you a really, really brief overview. But check these projects out, and if you're interested in participating or contributing or supporting this work, there's a variety of ways you can do it, one of which is to go right to the support tab and make a donation. So I much prefer if you had funds you wanted to put into the world of coding and creative coding, I would much prefer that you donate to the Processing Foundation than to the coding train directly. You're welcome to do both if that fits your fancy, but Processing Foundation needs a lot of support. Okay, and I am just quite fine. Thank you very much. All right. Well, the world has arrived. I wasted enough time that there are now quite a few people watching, and I think I can get on to doing some coding. So let me make sure I have all of the tricks of the trade here going. Here's my whiteboard. I'm going to write up here, Chapter 2, Forces. Okay, how's this looking, everybody? Think I'm ready to get started. Caps lock is on. Okay. Okay, I gotta stop looking at the chat. So, I have to screw my head back on here. So let's make a little outline for myself, just so I can kind of imagine what's going on. So the first if I'm thinking about the tutorials that will end up in this section, first is what is a force, and then the apply force function. Then we're going to say dealing with mass and gravity. Then I'm going to like two objects. Then I'm going to look at friction, drag, gravitational attraction. Honestly, I think that might be the whole kit and caboodle here. Let's look through the chapter. I've actually rewritten this chapter quite a bit, but okay. Then I think what I want to do is traction. I mean, I sort of have a coding challenge about this, so I might not need to. Propulsion and let's just wall force. Okay. Okay. All right, so this is my outline. So if all goes according to plan, which it never does, there will be 6 videos in the Chapter 2 section. I will feel quite satisfied if I can get to here today. So that's kind of my goal. Okay. So let me go back up to the top. I think I can leave this here. Offbeat writes, I'm really like appreciating Offbeat's chat. Maybe he needs to prepare a little bit beforehand. Have you watched the gunning train before? I guess not. My sort of thing is not preparing beforehand. I agree. It would be nice, and maybe would even make this better. Someday, perhaps. Okay. All right. Let me duplicate this. Two forces, one. I really have trouble getting started, but I'm going to just get started. In here we go. just as a little just to center myself here. $91,069, $74,603, $78,005, $80,158. Okay, I gotta start. I'm having a really hard time. A script would really help. Welcome to Chapter 2 of The Nature of Code, Forces. So I want to begin this chapter with a discussion of Newton's laws of motion. That was something out of a horror film. Oh, you know what? I forgot to set my record to disk thing. It's a good thing I had a little momentary brain freeze there. This is recording, and now I'm going to say multi-quarter go. And we're just going to hope that this works. I will check it in a little bit. So now I just need to get this up. I need to get this up. And this. There we go. Okay. Hello and welcome to Chapter 2 of The Nature of Code, Forces. So I want to start with this discussion by talking about Newton's laws of motion. So by no means is anything I'm going to do be a really accurate, robust physics simulation. But at a minimum, I want to examine what the basic laws of motion are, the basic principles behind how things move, and just make sure that the code I'm writing, fits with that for the most part. So let's start with those laws of motion. Do I want to come over here? Yeah, I will. I'm going to come over here. And hold on, let's look here. Okay. Law number 1. This is how it is often referred to most informally. An object at rest stays at rest. However, I think a more accurate way to, and an object. I bet you will change G. Can I make this a little bigger? Yeah, let's do that. Don't anger the physics. However, a more accurate statement of this might be an object at rest stays at rest and an object in motion stays in motion at a constant speed and direction unless acted upon by an unbalanced force. So that's a bit of a mouthful of stuff, but let's unpack that for a moment. Let's think about this in the context of our P5 canvas. And the object being a circle that I'm drawing on that canvas. If this circle is going to obey Newton's first law, it shouldn't move. What? If it's not moving, there's no reason for it to start moving. Or if it is moving at a particular velocity vector, there's no reason for that velocity vector to ever change unless acted upon by a force. The definition that I offered over here says unbalanced force because it is true that, yeah. The definition that I offered over here says The definition that I offered over here uses the term unbalanced force. So something that's very important about this concept of staying at rest or staying at a constant velocity is that it's not just whether the force is there or not, but whether the net force, the sum of all the forces in the environments, add up to something non-zero. For example, with my marker here, there's a force of gravity. For example, with my marker here, there's a force of gravity pulling it down, presumably towards the center of the Earth. But there's also some other forces that I'm applying to it to keep it up, that are pushing it up. And so, if I try my best to balance the force, then it won't move at all. This is maybe a better diagram. It's showing this circle, this is maybe a better diagram. It's showing this ball, as referenced by this circle, not moving because the force of gravity, the tension force, and the force of these breaths all balance out. They're all equal. They all net down to zero. I don't know, do I want to? Equilibrium. Let me look at that. This diagram is another This diagram is another example of this. So all of these forces balance themselves out, and this object is at a state of equilibrium, meaning it won't start moving, or if it were, its velocity would remain constant. And the reason I'm harping on this so much is I really want to make sure when I go to write the next bits of code that I'm going to write, that the simulation obeys this law. But in order for it to obey this law in the first place, I have got to understand, I'm using the term force all over the place. It's really important that I think I take a moment now to define what I mean by force. Oops. A force is a vector that causes an object with mass to accelerate. That is the technical definition that I am going to use for force. Here's the good news. Vector, check. We've got that. I just did a whole section of videos about what is a vector, so we can understand force as a vector. Here's more good news for you. Accelerate, check. I just did a video tutorial about how to apply acceleration in a P5 sketch. So if we can create a vector and somehow have that vector affect the object's acceleration, then we are implementing a force. And if the way that we implement the force in our code obeys this law, then we are golden. Yeah, the moon, oh boy, all the stuff. I forgot about the moon and magnetic fields. Greg writes, watching live is too painful. I agree. Just think about how painful it is to do this live. Think of all the pain that I'm in. I'm suffering. I've actually got a big smile on my face. I really quite enjoy this. All right. What do I want to say next? All right. Let's now move on to Newton's second law. Oh, actually, let me say something. Now, one thing here, mass is not something that I have discussed or used or implemented as a property of any of the things I've done so far. So let's put a question mark there and return to that, which leads me to Newton's second law. F equals m times a, or force equals mass times acceleration. This is the fundamental law by which everything I do in just about every example throughout the entire nature of code will be fundamentally tied to. I can also restate this law. Sorry. I can also describe this law as a restatement of the definition of force. Force is a vector that causes an object with mass to accelerate. Let's look back. Oh yeah, I had a bunch of stuff in here. Let me just give me a second here. I'm just going to take this out for a second. Yeah. Yeah, there you go. All right, sorry. Okay. Isn't general theory of relativity the newest theory of gravity? Yes, yes, yes. Maybe I need to address that. I think I'm okay. I'm noting Kay Weekman's comment in the Discord supporter chat. I'm a little bit concerned about the way that I wrote stuff on the whiteboard, but I think I'm kind of okay. All right, so hold on, where was I? Here, okay. Returning back to the code for a second, you can see here that, returning back to the code for a moment, I have these two lines of code. Velocity add acceleration, position add velocity. And in this example, everything starts with acceleration. I'm calculating an acceleration based on a vector that points from the object moving to the mouse itself. So if everything starts with acceleration, maybe I need to rethink the way that I'm describing this formula. And a different way that I could consider it is acceleration equals force divided by mass. The idea being that if I introduce some force, like let's say there's a wind force with magnitude and direction that I want to put into this environment, if I have that force, I could take that force, divide it by this object's mass, and that would become the object's acceleration, which would then affect its velocity, which would then affect its position. And this is the technique, the strategy by which everything I do is going to be built upon. I'm really ready to start putting this in code, but there's a few things I want to address before I get there. Number one is you might hear, number one, I'm really ready to start implementing this in code, but before I do so, there's a few things I want to address. One is you might hear the term, when looking at how physics engines are built, the term integration. And this is actually one way of doing integration. This specific way is referred to as Euler integration. Now, why is it called integration? I'm getting into the weeds here, into the math aspect of this, but it is important, and I think this will help you as you move forward and do more of this stuff when you see the lingo popping up here and there. In calculus, there's the concept of a derivative. And I can think, you might typically see this as written as like dx over dt, meaning the change in x over time, the change in x with the change in time. This is actually what velocity is doing. Velocity is dx dt if x is position. Velocity is the change in position over time. Acceleration is the change in velocity over time. So there is a process. So velocity can be thought of as the derivative of position, and acceleration can be thought of as the derivative of velocity. But I'm not going in that direction. I'm not starting with position and then figuring out what's the velocity and then figuring out what's the acceleration. I'm going in the other way. I'm starting with what's the acceleration and then changing the velocity and then taking the velocity and changing the position. So the other direction of doing the derivative is integration, the integral. So that's why this process is tied to calculus and the concept of integration. The big difference here is that calculus being the study in a way of infinitesimally small time steps, these time steps are quite large. I'm only doing 30 times per second. 30 times per second, I'm applying this algorithm. 1, 2, 3, 4, 5, 6, 7. I can't count that fast. This algorithm is just being applied 30 times per second. But time, as I move my arm back and forth, are you seeing this animation at 30 frames per second? Maybe because you're watching a video, which is then recording me and playing it back at 30 frames per second. But the actual physical time space that I'm in is very continuous. There's no time step. The time step is infinitesimally small. And if I were doing an accurate calculation of a physics simulation, I would need to take that under consideration. Instead, I'm using a technique called Euler integration, which allows me to have fixed time steps, which are rather large, and it's wildly inaccurate. And I'll maybe circle back to this as I look in future videos about other integration techniques. There's Verlet physics, and there's Runge-Kutta integration. I probably didn't say that correctly. And so maybe I can circle back when I look at other physics libraries that might have slightly more robust methodologies underneath the hood. But the reason why I like this methodology is, number one, it works just fine. Like, I just want my particles to spiral around the screen in pretty ways. And two, it's really fast and really easy to implement. So it has its advantages in terms of the kinds of examples and demonstrations that I want to show you. Physicists are screaming Planck time. I'm going to need some sanity checks on my explanations here in the supporter chat if I've really gone way off and Planck. Also, I know there's so much more to this. Before you start typing your comments in the chat about the theory of relativity and space-time continuum and Planck time and also Planck time, I don't even know how to say it. Just realize that this is not, my goal here is not to go in depth into the physics of this, and I'm glad to include in this video's description other resources that do, but to take these ideas, these core kind of classic concepts, and then work out a way to implement them in code. Does that need to be included? Uh, All right, I'm seeing a lot of typing going on. I'll also mention there is a third law, Newton's third law, which is often stated as for every action there is an equal and opposite reaction, which I'll say is quite misleading, and I've written some text here in the Nature of Code book about that. I think a different way of stating that law is forces, oops, that mouse was not in the way. Momentum. Okay, no, I can't talk about momentum. Right. I should also mention there is a third law, Newton's third law, which is often stated as for every action there is an equal and opposite reaction. That's a little bit misleading, and I've written some thoughts about that here. Another way of stating that law is forces always occur in pairs. The two forces are of equal strength, but in opposite directions. So, to be honest, this law is not so meaningful to me right now. I mean, trust me, it's kind of important, but in terms of the simulation that I want to start with, I am not going to bother to simulate every possible reaction and opposite interaction of every force within the system. But this will come up again, and I will look at this law when, in a future video as part of this section, I look at gravitational attraction and how two bodies both attract each other. And those forces have an equal and opposite, and those forces are of equal strength, but in the opposite direction. Okay. Yeah, the changing the time step thing is important. Okay. This is going pretty well, I might say. I mean, I sort of felt kind of cruddy this morning, and I'm quite surprised with how I feel like this is going. Let me just check. Because it's going so well, I'm going to take a minute here to check my recording system, which has been having lots of problems. I mean, ultimately, these videos can always just be edited out of what you're actually seeing. So what you're actually seeing is being recorded to disk, and I've never had a problem with. But behind the scenes, I'm recording separately the different the green screen thing, the screen capture. Oh, I meant to, let me actually do this as a backup. Give me a second here, screen recording. Let me just do this as a backup. No, oh wait, hold on. Options. I want to make sure I have a mic. Yeah, that's fine. Record. So I'm also going to record it here because sometimes it's helpful when Mathieu and I are putting this together to have all of the raw stuff. So let me just check if you don't mind. I'm going to just check for a second. Talk amongst yourselves. All right, I realize what's the point of me checking it? Like, if it's not working, what am I going to do? But it's hard for me to tell. It looked like it might be a tiny bit glitchy, but it certainly wasn't like obviously really bad. So I'll just sort of like hope that it's working. I'm going to hit record again. Now it's recording again. Actually, I think it's better if I don't minimize that. That's just maybe superstition at play here. Let me go back to here. OK. All right. All right, I'm going to look at my phone. Stop looking at your phone. Stop looking at your phone during a live stream. Blah! It should be obvious. I'm talking to myself, not you. You're fine. You can look at your phone. You are totally, look at your phone. Now, if you're taking a class or attending somebody's presentation, it's a little bit rude to look at your phone during it. I mean, I admit it, I've done it. I try not to. I try to give my full attention, put a smile on my face, nod my head when I'm listening to somebody speak or present. But you, I can't tell. Look at your phone. It's no problem. All right. So next up, I mean, this could, in theory, be its own. I think I'm going to just, I never know when to break these videos up. In theory, this could have been the end. But I think I'll just keep going and add some code because it's just a few quick things that I want to do. All right. Okay. To start implementing Newton's second law in code, I'm going to build off of the example I finished with in the previous video in the vectors section. So there I have this single mover object. It starts at location 200, 200. You don't want to say location. Position, 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 position. When I was a physics man, diddle, deedle, deedle, diddle. Okay. Position. I just only knew the other lyrics that I could keep going with this. To get started implementing Newton's second law in code, I want to build off of the example that I finished with in the previous section on vectors. So here I have this mover object. It starts at a position 200, 200, and two functions are called, update and show. And so if I run it, it's the acceleration is being calculated as a vector pointing towards the mouse. You could think of it as a force, a gravitational attraction force pulling into the mouse. Now, it's not really that. I mean, of course, it's not really that. It's just some like pixels on a screen. But it's not even, I'm not even using the formula for gravitational attraction. So I'm going to circle back to that and make some changes to this kind of idea later. But right now, what I want to do is change the way the internals of the mover object works. Because right now, the acceleration is being calculated right here in update. And I don't want to do that. Instead, I want to write a function that's basically Newton's second law. So I want to write a function, I'm going to change its name in a moment, that implements this particular law. Now the law, again, is force equals mass times acceleration. But I've rewritten it to acceleration equals force divided by mass. Guess what? Let's just pretend for a moment that the world we live in, the world that I'm programming in, there's no concept of mass. In fact, everything in this entire universe has a mass of 1. If I were to do that, and I'm rewriting the law as force equals, So in that case, going back to this law of force equals mass, which is 1 times acceleration is really just the same as force equals acceleration or acceleration equals force. So these are the same concepts. Meaning I could just say this dot acceleration equals force. There we go. This is the simplified version of Newton's second law in code. I'm going to change the name to apply force. The idea being that what I want to do is take a force that exists in the environment, not something calculated from within the object. That's going to be important later in some of the other videos I'll do. But right now, imagine a wind force external to the object, or a gravitational pull, maybe pulling it down along the y-axis, external to the object. For example, let gravity equal create vector 0, 1. I'm making a vector that points down, and then I want to say mover, apply force, gravity. Let's run this code. Remember, this is the apply force. It sets the force, sets the acceleration. Remember, this is the apply force function. It sets the acceleration equal to the force, and then that acceleration is added to velocity, and that velocity is added to position. Oh, that's not good. Oh! I forgot that I'm programming in a class, and in a class, I don't use the keyword function to define an instance method of that class. I just say apply force. Oh! There we go. Look at that. There's that force of gravity pulling it down. I'm thinking. I mean, as you could probably tell. Now this sketch is a little bit sad because the ball falls and it never comes back. So just for the purpose of demonstration, I'm going to add an artificial constraint to this particular sketch, where what I'm going to do is I'm going to look at this bottom edge, and if this circle reaches the bottom edge, I'm going to take its velocity and reverse it. Now, really, if I were doing physics simulation, I would think about this as an object with a different mass and what kind of forces are happening when it hits that object. But I'm going to just bypass all of that with a quick shortcut. I will come back and look at that a little later, maybe, but I'm going to bypass that with a quick shortcut of just inverting the velocity. And I'm going to do that by adding a function called edges to keep track of when the object hits an edge. So this is really your classic bouncing ball code, and I have another video that kind of goes through this algorithm more specifically. But what I'm looking for is anytime that y position is at the bottom of the canvas or below, right? Because it might, testing if it's equal to height is not going to do me any good. If it's not precisely equal, it could easily move past. Then I'm going to shove it back up to height, because if it goes too far and it turns around, it could get stuck. So I'm going to make sure, even if it goes past height, I set its position to height and then reverse its velocity. And let's take a look. Oh, that didn't work. Oh, why didn't it work? You know, it's one thing to write a function. It's another thing to call it. So let's say mover.edges. And there we go. So now this gravitational force is pulling the object down, and it's bouncing up and down. Now, why is it going off to the right a little bit? It's going off to the right because I gave it an initial random velocity. It's also interesting that it did get stuck. Weird. Why did that happen? I'll examine that as we go, but I want to just change this now for simplicity to just giving it an initial velocity of 0. And let's examine if Newton's first law is working. Wow, why did it nicely slow down and stop like that? I really shouldn't read the chat. I don't know if this is referring to me, like do I have food stuck in my teeth? Somebody's talking about how I don't brush my teeth. Maybe they're talking about somebody else. Why do I look at the chat? Why? That's weird. No, I was going to address this, and I was going to do something like this, which would actually cause it to do what is there some kind of rounding thing going on? Oh, I think it's the shoving it back up. It's got less time to go back up to the top to regain its full velocity. That's what's going on there. Ugh. Okay. I just, you know. It's actually kind of like what I want it to do. But it's also just wildly inaccurate because of the Euler method. I mean, do I really care to address this? All right, I will. Interestingly, you notice how it's like slowing down and eventually getting kind of losing its bounce and stopping? In a weird sort of way, that's kind of what I wanted to do. That feels realistic. But I can't see in the code why it's doing that. Because really, I'm reversing its velocity. There's nothing causing it. It should go all the way back up to the top and then all the way back down and then all the way back up to the top. And this, I think, is because of this Euler integration. I'm not looking at continuous time. And there's a lot of inaccuracies here. Not to mention the fact that I'm violating all of the principles of time and space by just resetting its position back to the height if it got below the height, so it's losing some time where it might regain its velocity moving back up. So there's all sorts of goofy stuff going on here, and these are the kinds of things that as a programmer working with this in a creative context, ultimately I'm going to be massaging and sort of like tweaking things to get it to feel right, whatever the types of application that is that I'm wanting to create. But right now I just want to test if Newton's second law is at play. And I'm going to test that by doing this. Only if the mouse is pressed, apply this force of gravity, meaning the net force is currently 0, so the object is at rest. Now I am going to apply the force, but I'm going to let go. Oh! Ah! I forgot a really important detail. I didn't forget this detail. I knew I had to get to it, but it actually just came up right now. So why not get to it now? Weird, right? I'm applying gravity, but when I let go, I think the gravity should stop being applied because I'm no longer pressing the mouse, but the gravity still seems to be there. Why is that? Well, there's a flaw in the way that I program this. And the flaw is that I'm setting the acceleration equal to force. The flaw is that I'm setting the acceleration equal to force. If the force goes away, I don't set the acceleration back to 0, but I should. So one of the strange things about this Euler integration algorithm is that while velocity and position are accumulating over time, acceleration is just a function, a calculation based on at any given moment in time, what are the forces in the environment? So at any given time, we should start with an acceleration of 0. And there only is an acceleration if there only is an acceleration if there is a non-zero force. So there's a variety of ways I could implement this. I could have like a reset function that resets the force to 0. So there's a variety of ways that I could handle this. I'm going to just, I think for simplicity, just say this dot acceleration set 0, 0. So this is me just clearing the force out at the end of every animation cycle. So now let's see if Newton's first law is really at play, and the second one. Set. Seriously? Did I do something weird? Oh, interesting. Oops. Another bug. Cannot read property set of undefined, because I haven't given acceleration a value until I've applied the force. So this is just a flaw in how I've written the constructor. I also need to say initialize a starting acceleration of 0. And now, here we go. All right. The object is staying at rest. There's no force. I click the mouse. Whoop, whoop. I let go of the mouse, and it just flew off. Let's make the gravity less strong. I'm going to change this to 0.1. I'm holding down the mouse. There's gravity. I let go. The gravity is gone. The object keeps its constant velocity because there's no force acting on it. Let's try also now adding a second force into the environment. So there's one force pointing straight down called gravity. Let's add another force called wind and point it to the right. Let's get rid of the if mouse is pressed. I'm going to, oops. Let's get rid of the if mouse is pressed. I'll come back to that in a little bit. So now I've got gravity pointing down and wind pointing to the right. Now, of course, I could have just made one force with this as the x component and this as the y component, but I'm demonstrating an idea that as you start to build these kinds of simulations, there might be a variety of forces that are at play or not at play based on any number of factors, and you can now separate those out into different vectors and individually apply them to your object. Let's run this sketch and see what happens. Wait a second. Now this I anticipated, this error. Why is gravity not being applied? I only see wind. All right, let's change the order here. Let's put wind. I don't know, let's like move the code around a little bit. Like let's declare wind and gravity there, but now apply them like this. I don't know, is that going to do anything? Wait, now only gravity is being applied, but not the wind. Think about this. Go back into the mover. What's wrong? This dot acceleration equals force. So stepping through the code, mover apply wind. This dot acceleration equals wind. Mover apply gravity. This dot acceleration equals gravity. I just overwrote the wind. The wind is ignored because I take gravity and put it into acceleration. As I was diagramming this and describing it, I think a couple of times I used this term net force, or the sum of all forces, or this idea of force accumulation, meaning the object's acceleration is a result of the sum of all of the forces in its environment at any given time. Wind and gravity both act on the object and both get added into the acceleration. So this apply force function shouldn't actually set acceleration equal to force, but rather it should call add. This dot acceleration dot add force. I can call apply force as many times as I want, and I can call apply force as many times as I want and add up all the forces into the acceleration. There we go. Now the visual result of that isn't super interesting. Let's make it a little more interesting by saying and I'll make the gravity a little stronger. So now the wind will only be applied if I click the mouse, but gravity will always be applied. Let's see if this works. There's the ball bouncing. And now I'm going to click the mouse and the wind. Oh, let's add some more edges. So now I've added a check for the right and left edges and make sure the x slides back onto the edge and the velocity is reversed. And there's probably a more elegant and efficient and shorter way to write this, but I'm just putting it in there to get it to work. Let's see how the forces are going. Gravity, and now I'm going to click the mouse, and wind is happening. You can see that the wind is like pushing it in that direction, but let's let go of the mouse. And now the wind is no longer there, and it's bouncing back and forth. The x velocity is constant now because there's no x component to the net force. But I could add the wind back in, and we can see now it's pushing it to the side. I could also just sort of increase the relative strength of these forces just to see what that looks like. And we can kind of see that here. And we see I already have a pretty interesting and dynamic simulation going. There was something important I wanted to say about this. Yeah. I think I'm trying to think of what else I want to say about this. Oh yes, thank you. Tio actually just mentioned it in the chat. It was in my head to do that, and then I forgot. This is a small detail and not super important in terms of what I'm doing, but it would be nice to actually have the edge of the circle. Sorry. But it would be nice to actually have the ball reverse its course when the edge of the circle hits the edge of the canvas rather than the center of the circle. So in that sense, I could add another variable for r to keep track of the object's radius. So I'm going to say this dot r equals 16. And then draw the ellipse as this dot r times 2. And then use this dot r as a, and then use this dot r to determine where the edge is. Let me have it move a little slower so this is hopefully a little more visible. Ooh, oh, whoa, I forgot something. I've got to set it back to this dot r. There we go. So that's a little bit more realistic in terms of like where it's actually bouncing, in terms of hitting the edge. There was that. All right. Let me go back to my outline because let me just understand what's coming next. Two objects dealing with mass and gravity. Great. Now, this is something you can start working with. I mean, think about the way that I've created these forces. now I've got something hopefully you can start working with. Think about the way that I created these forces. I just hard-coded some numbers in there. Maybe the wind force is a result of some other kinds of algorithm. Maybe it's coming from a data source. Maybe it's using Perlin noise. Maybe the interaction isn't just whether I click the mouse or not. Maybe there's more than one object in the scene. Maybe you're using color and other types of designs to create a pattern. But this is something that you can use as a foundation to build examples upon. Now, I want to do more with this. So one thing that I've completely ignored here is this concept of mass. It's kind of like a little jerky, the animation, but I'm not. Yeah. There's a couple things that I want to add here, which I'm going to do so in the next video or two. One is the concept of mass is completely ignored. So how do I deal with mass, and how could I have this mover have different mass? This is hopefully a foundation upon which you can build an example or a project. No. I kept up trouble with the end of these videos. All right. I got it. So this is a good stopping point for this example. I think there's a lot of twists you could do on this. I mean, first of all, I've just hard-coded numbers here for wind and gravity. There might be other ways you think about calculating those. For example, you could actually pull from like a weather API and get the actual wind and have that affect this object. Or you could use Perlin noise. Maybe these vectors are like changing over time for some other reason, or there's more than two forces. So many ways you could go in this direction, but this is a bit of a foundation upon which you could build a simple interactive simulation. There are a couple of different things that I want to do with this example, which I'll do in separate videos. Number one is there's no concept of mass here. So what would it mean if I added to the mover object a mass property, and how would I use that mass value and actually bring that back into the true Newton's second law, force equals mass times acceleration. So I want to bring back mass. Bring back mass. Then I also want to investigate other forces that I can look up the sort of like real world formula for and see if I can implement those. And the first one I'll do is friction. For example, there's this thing happening where the ball comes to a resting point, but then it just rolls back and forth. Could I simulate sort of friction of it against the edge and have it slow down and reach a stopping point? So the next video I'll start with mass, and then I'll look at friction and keep going from there, finishing up with looking at the real formula for gravitational attraction and how I might implement that in code. So maybe I'll see you, maybe I won't, and go on with your day. May the force be with you. I said it. Goodbye. All right, everyone. That was good. It's time for a short break. I've got another hour to go. Before I take my short break, I'm going to thank the sponsor of the coding train, Brilliant.org. I mean, do you like the math and physics stuff? Let me tell you something. If you like the math and physics stuff, I think you're going to like Brilliant.org. So Brilliant.org is a website. It has many things on it. It's a problem-solving website with a hands-on approach. There's 60 interactive courses in math, science, and computer science. It helps you achieve your goals in STEM, one small commitment to learning at a time, because you could just do like a quick little 5 minutes every day, 10 minutes, 15 minutes. You could spend all day on Brilliant, or you could just do it a little bit. I enjoy looking at it on the subway, so I spend a lot of time commuting, and that's like a really helpful time for me to do a quick puzzle. So one of the things about it is that's great in relation to the things I'm doing on my channel is it has a computer science fundamentals course and a fundamental algorithms course. So algorithms are the bedrock of any education in computer science, and studying them usually involves fighting through the specifics, the details of syntax. And so one of the wonderful things about the fundamentals of algorithms course and computer science courses on Brilliant is it allows you to really think abstractly about the concepts and do a lot of different interactive puzzles. I will say there's drag and drop programming with pseudocode and all sorts of other fun stuff. And it kind of like the video was there. And it's looping, and it's not at the point where I want it to be right now, because after these puzzles, when it gets to this spot, what's new about Brilliant, I don't know how new it is, but it's new to me, is that they've actually built Python now into the browser. So while I use JavaScript mostly and Java in my tutorials, Python is another great language that you might be interested in learning, and it's part of a lot of Introduction to Computer Science curriculum. And you can actually type and do a lot of the lessons with interactive Python right in the browser. So I'm going to let that pop back up again and see. They have a new chemistry course, which is also pretty interesting, and a lot of other interactive content. I really like their math fundamentals course. There's the Python stuff as well. So now, what I like to do before I take my break, and I'm so excited about what I saw was there, is I like to go to the Brilliant website and look at what the day's, one of the daily challenges. So this one, I want to look at one ray only. And the reason why I'm excited about this is raycasting coding train. This really relates to my coding challenge 145. So I'm going to quickly try to solve this puzzle. I looked at it earlier. I didn't actually click on the answer, but I think it's going to be an easy-ish one to do. We'll see. It'd be interesting for those of you when I take a break, if you want to sign up for Brilliant and offer your own take, maybe there's something in this code example that can actually link up with it. Okay, so let's look. Okay, so today's challenge. A sealed box contains a blue light, a green light, and a red light on the wall. Let me get the chat back up here so I can see it. So it's now not seeing it. And a red light on wall. The other three walls are covered with perfect mirrors. To see inside the box, there's a narrow eyepiece, which makes an angle of 60 degrees with the wall, which I think is what's right here. This is the eyepiece. It's interesting how the arrow is pointing in that direction. Oh, because we're seeing the light come back in. That's where you're looking. So we've got to find where. I'm thinking of the sort of the vector going out. And where it's going to go. It's obviously not going to reflect like this, right? The angle of, what do you call it, incidence? Anyway, this should reflect equally. So if this is 60 degrees, this is 30 degrees. So the reflection should come off 30 degrees. So I think the idea is that I've got to solve for which color it's going to end up on. So I can use this interactive thing here, and I want it to be 30 degrees. 30 degrees. So it should be that. Then I'm going to go to the next angle, right? And then that should be 60. Right? 60. And then the next angle would be 30, like that. And then the next angle would once again, I assume, be 60. Or no, 30? Yeah, it looks like, yeah, not 60. Yeah, that's also a 30-degree angle. So it looks like this. So the answer should be green. I don't know. Did I do this right? I think I did. I'm going to click on green. I'm going to click submit. Anybody want to stop me? Stop me now. All right. I got it right. So what I like about is I could see other people's explanations, and I could write my own. I mean, if I had the time, wouldn't it be nice to just make a P5 sketch that re-implemented all this interactivity? And this is the thing. This is why I like, because I get these ideas. I'm like, oh, I would love to make a P5 sketch that basically does this interaction. And I kind of have already, because that's ultimately what's happening in this raycasting coding challenge. It's just sending out lots and lots of rays of light, and I'm not doing the reflection. I just realized I'm not doing the reflection here. So that would be an interesting thing to add to this, the reflection. I know the community contributions have reflections. There you go. So if this seems like it's of interest to you and you want to take a minute to sign up now while I take a short break, go to brilliant.org/codingtrain. You can sign up for free and put your own answer into that puzzle. I mean, I guess you're probably going to put green in, but maybe put your own explanation in there. If you make an explanation, write it in there, share it with me. I'd love to find out about it. And I will see you back in about 5 minutes. Oh, and of course, if you want to unlock all of the courses on Brilliant, You can, if you go through that link and order a premium subscription, the first 200 people to do that will get 20% off, and that unlocks all the content that's on Brilliant.org. All right, I'll see you in about 5 minutes. All right, I am back. Thank you again to Brilliant.org for the sponsorship of the coding train. I hope you enjoyed this daily puzzle. And I am now moving back on to where I left off. Titan, oh, you shared the link. So sorry, Titan, I can't, it's hard for me to like keep track of things that fly by in the chat very quickly during the live stream, but maybe somebody who is in the supporter group on Discord can capture the link and share it with me later. But Discord is the best place to share stuff with me after the fact, or social media. You can tag me at Schiffman on Twitter is probably what I check the most. Okay, so now let me close this stuff and let me do duplicate, and I'm going to forces 2, and we're going to add mass. All right. So I'm trying to think. I'm gonna go until noon. So that's about 45 minutes. 2.5 hours. I mean, 2 hours is my like wish for a live stream. I often get into 3 hours and beyond because sometimes it's hard to stop. But mostly I don't think that as wacky as it sometimes gets, if I get a little punchy, I don't think I produce a ton of valuable content after 2.5 hours. So that's certainly where I'll stop today. I forgot to get water. I'm a dum-dum. Okay, I might have to take another short break to get water. This is finished. All right. So I'm trying to think. So the next two things are mass and friction. These will be pretty short. Well, mass will be short. Okay. I'm going to erase some of this stuff. Okay. Okay. I mean, my goal is to get through mass and friction. And then I'll be coming back to this stuff. Oh, you can't see me. My goal is to get through mass and friction, and then I'll be coming back to this stuff 4, 5, and 6 on the next live stream, which will most likely be a week from today. Okay. Welcome back. I should have asked people in the previous one to try mass and friction, but I've got to get water. I'm really sorry, everybody. It's very, very fast for me to get water. This was completely, I mean, what's the point of me taking a 5-minute break if I don't actually go get the water during it? I don't know. I did some other stuff. I checked my messages. I went to the bathroom. You know, I had to do that. So let me, just give me, it's going to be like, I would say around 60 seconds for me to get water, okay? I went and got water and then I probably drank all of it. Do I need to go back again? I was really thirsty. Hopefully that will tide me over. All right. Welcome back. In the previous video on I like how people are counting in the chat. Welcome back. In the previous video, in this section on forces, I built this particular example where there are two forces at play. A gravity force that's always being applied to the mover object, and when I click the mouse, a wind force is being applied to the mover object. What I want to do in this video is look at how I might consider this mover object to have the property mass, and how that might affect how the gravity and wind forces behave. And in truth, for me to be able to demonstrate this effectively, it's only meaningful if I have two objects with different masses. Because if I just have one, scaling the mass is just something that will ultimately scale the strength, the relative strength of those forces. So let's quickly add a second object to this example. Now you might already be thinking to yourself, ugh, what did you just do there? If you're going to have more than one object, shouldn't you use an array, or isn't there a different way of doing this? And yes, yes, yes. And ultimately what I want to do with these examples is build arrays into them to collect many objects and sort of add and subtract them from the canvas itself. But just for demonstration purposes, I'm going to leave these as two separate variables, mover A and mover B. I'm going to apply both forces to them and call update edges and show on both of them. Let's see if that works. There we go. Let's apply the wind. Kind of interesting to see them now doing something there. You can see how they're kind of in lockstep together. Maybe mass will change that. Okay. Sorry. Looking into the mover class itself, where should I incorporate mass? Well, I do have this variable this.r, which is being used for the size of the ellipse. I could add another variable, this.mass. Let's just set it to 1. I'm thinking. I know what I want to do here. So both are bouncing and responding to the wind force. Now let's think about where I want to add mass. So looking at the mover object, there's position, velocity, acceleration, and r. And r is a property that is tied to the size that I'm drawing the ellipse. Let's just add mass as its own property for a moment. This dot mass equals 1. Oh, so many things are going to come up with this. Ah, so good, so good. And remember, the reason for adding mass in is Newton's second law, force equals mass times acceleration, or acceleration equals force divide, whoops. I might actually not get to the friction, because there's more to this than I thought. And the reason why I want to do this is, remember, Newton's second law, force equals mass times acceleration, or restated as acceleration equals force divided by mass. And remember, the way that I'm implementing this is all of the forces divided by mass are being accumulated into the object's acceleration. So first and foremost, I need to add this, I need to incorporate this divide by mass into my apply force function. Right here, I can then say force dot divide by this dot mass. Right? Before I add the force into the acceleration, divide by mass. Let's try running this. Okay, good, same result. Well, the mass is just 1. So let's now add mass equals 2, which I should see the acceleration. The force remains the same, but the strength of the acceleration should be divided by 2, divided in half. Wait, what's going on? Something's weird going on. Why are they different? They shouldn't be different. They don't have different masses. Something's crazy is going on. Think about this. Do you remember this video I made a little while ago where I talked about static functions? Now we'll do like a flashback. Oh, you should do that. Let's do like a weird flashback thing. Do you remember, a few videos back, I spent all this time talking about static functions. So we'll do some clip there. There was a purpose to that. There was a meaning to that. There was a reason for that. And that reason, that moment, is right now. This is the case where I want to divide force by mass, but I don't want to affect the actual force. The wind is not being divided by half. The wind is going into the object, and the object is going to divide it by half to put it in the acceleration, but the wind must remain the same. The issue here is I am actually taking this force and dividing it by half. So I want a new vector, and I'll just call that F for simplicity. And I want to say F is the result of dividing force by this dot mass. I don't want the force to be affected. I just want to divide it by mass before I put it in the acceleration. And this is happening because right here, this wind vector is being applied twice. So wind gets divided by half. Sorry, not divided by half. Am I saying divided by half again? Wind gets divided in half, divided by 2. Wind is divided by 2 and is smaller when it goes into mover B. It's the same wind in both of those. But both of those objects should divide wind by its own mass before adding it to the acceleration. So this static version, oh my goodness, of the divide function, which is what I meant to put there, this static version of the divide function Can I just go back for a second? Because this all got convoluted. Except I don't remember what I was doing. Well, it'll all get figured out later. This is the very reason, the moment right now, where static methods are important and we're going to make, whatever I did before was so much better. All right, fine, keep that. I want to divide force by mass, but not the actual force vector itself. I just want to take that vector, get a copy of it, divide it by mass, and then add that to the acceleration. The reason is because out here, right, I'm taking this wind vector and applying it to A and B. And I don't want A to mess with it because wind should stay the same when it applies to B. But this function itself is actually taking that force vector and dividing it by 2 and changing its value. So there's different ways I could do it. I could make a copy of it and then divide it, but I could also use the static version of divide. In other words, I could say, and I need a new vector to store the result in. I'll just call it f, p5.vector.divide this.mass. So instead of, force, comma, this.mass. Shoot. p5.vector.divide force by this.mass. So here I am saying, take that force, divide it by mass, and store the result in a new vector f, and then that vector f is what gets applied to the acceleration itself. Oh, and of course I need to remove this line of code, which I no longer want, and there we go. So now mass is playing a role, but it's not actually adjusting the forces. Oh, I don't know what I was going to say. So now mass is playing a role, but it's not affecting externally the environment, and it's just a property of the object that's affecting the way the force changes the acceleration. So let's take the logical next step and give each of these objects a different mass. So I'm going to add a third property to the constructor, call it m. And then when I create the objects, let's give one a mass of 2 and one a mass of 4. And again, I'm just picking numbers out of a hat, totally arbitrary. So remember, the one on the right will have a higher mass than the one on the left. Oh, interesting. This is correct according to Newton's second law, right? If acceleration is force divided by mass, if an object has a larger mass, it will accelerate less. And this makes sense. Think about the force that you have to apply to an object. An object with a greater mass is going to be, you're going to need a much stronger force to get it to accelerate than something with a much smaller mass. Think of a bowling ball, this is a ping pong ball. How much force do you need to apply to get those both to accelerate equally? But something weird is going on here, right? Because, maybe, what's the thing with, is it dropping like the objects from a tower? Is that Galileo? Yeah, Galileo's Leaning Tower of Pisa experiment. Something is really wrong here. Something is really wrong here. You might have heard of Galileo's famous Leaning Tower of Pisa experiment, where in the late 1500s, gravity is not the force. The force equals weight is weight equals, that's a good point. I'm kind of not using my terminology super correctly. This should really be called weight. Yeah. No, I know. So I'm gonna get, this is where I'm going, David. But thank you for that, because then I can change, I'm actually gonna change this to call it weight. So just bear with me for a second. We'll see if I address that. Something is not right here. You might recall, or have heard about, Galileo's famous Leaning Tower of Pisa experiment, where, as the story goes, in the late 1600s, Galileo is said to have dropped 2 spheres of different masses from the top of the Leaning Tower of Pisa. And did they fall? Did one fall faster than the other? No, they fell at the same rate, independent of their mass. And the reason for this is because the formula for gravitational attraction, or the force, the weight of an object, weight is actually a force, right? Yeah. Yeah. The weight of an object, weight being the force, gravity, I'm really using the wrong term here. I really should be saying the gravitational acceleration. The force is the weight, and the weight of an object is scaled according to its mass. The bigger the mass, the bigger the force. The smaller the mass, the smaller the force. So this would actually be accurate So for this to work more accurately, I should really say let weight A equal P5 dot vector multiply gravity times mover A dot mass. And weight B is that same thing, multiplying mover B's mass. And then I'm going to apply weight A and weight B. So this is a little bit, I'm like sort of fudging things a little bit just to like take this gravitational vector and then multiply, scale it according to mass before I apply it in, where it then gets divided by mass. Let's just see if this works. Perfect. They're both falling at the same rate. Now let's apply wind. Well, the acceleration is different, as it should be, because wind, the wind force, the acceleration of the object according to wind is not scaled according to its, well, it's the way it should be. The wind, the acceleration due to wind is less when the mass is larger, and that's the way it should be. But visually this is very hard to kind of watch here. The chat is kind of saying a lot of interesting things. The thing is, it's kind of hard to see what's going on here because I'm drawing them at the same size. So this is a nice moment for us to think about. If I have two objects, this is a nice moment for us to think about. If I have two objects, and I'm going to just erase this here. So let me erase all this. If I have an object, whoops. If I have object A, whose mass, how many times can I do this? If I have object A, and the mass of object A is 2, and then I have object B, and the mass of object B is 4. Well, certainly if the density of these things is the same, but what is the density here? I mean, these are just pixels, but let's consider the density to be the same, then I might want to draw mass B, object B, larger than object A. So one idea could be like, oh, the radius could be equal to the mass. So here the radius is 2, and here the radius is 4. But that's not really the right scale. Because what should really map, at least in my mind, to the mass is the area. So the area of this should be twice the area of this. What's the formula for the area of a circle? Pi r squared. So in that sense, I think a proper mapping would be to take the square root of the mass. In other words, yeah. Right, because, and why is that? Well, let's say the radius is 2. Let's say the square root of the mass, yeah. Let's say, in this case, the radius is square root of 2, and in this case, the radius is square root of 4. Well, the surface area, the area, pi r squared would be 2 pi, and here, pi r squared would be 4 pi. Whereas if I used 2 and 4, I would have 4 pi and 16 pi. Because I'd be squaring 2, I get 4, squaring 4, I get 16. So take that mass, take the square root of it, and apply that to the object's radius. In other words, this dot r equals the square root of this dot mass. Let's take a look at what this looks like. Okay, well, those things are so tiny. They're so tiny. So I'm going to scale it arbitrarily, multiply it by 10, and we can see this object has a higher mass. Now, why are they kind of bouncing out of sync now? Well, it's because they're hitting the bottom at different times because their size is larger, which is fine. That's visually what I want. And now you'll see the acceleration of the smaller one be much higher with the wind. Okay. I think I got to the end here. Yes. Ultimately, I'm making a ton of arbitrary decisions here, but I'm trying to make these decisions based on the way that I understand these aspects of physics working. And I'm sure you could think of some improvements to make on those things and those decisions. And so I hope maybe now what you could do is, what are some other ways you might think about visually representing objects of different mass? What if they have different densities, or they're made of different material? Or how might you have other forces in the environment that play a role in how this world is visualized? But the next step, okay. Let me sort of say that again, because now I know where I'm going with this. Ultimately, I'm making so many arbitrary decisions here, and there's many inaccuracies. But I'm attempting to at least take the ideas from real-world physics and apply them to the best of my ability in a way that feels accurate. So one of the things I might suggest to you are, there's things that you see that I've missed, things that are inaccuracies or don't feel right to you in terms of how, if these were physical materials, they would behave. Certainly they would collide with each other. That's a whole other can of worms to open that I'll come back to another time. But what types of elements can you apply to this? Could you add an array now? Could you think about how you visually design these objects? Maybe you want to represent different masses in a different way through color or some other way of visually indicating that. But for me, the thing that I want to do now is I want to revisit essentially what I'm doing in these two lines of code, where I say let wind equal create vector number comma number. Let gravity equal create vector number comma number. Is there not a better way or a different way that I might approach the calculation of a force vector in the environment? And that ultimately is looking up a formula for how a force is calculated based on the properties and conditions of the environment. And so the three forces I want to look at are friction, drag, which is kind of like friction but different, and I'll explain that, as well as gravitational attraction between bodies in space. So I'm going to look at those as kind of case studies and different formulas. Maybe you'll have some ideas of ways you can look at other forces or invent your own forces, but I'm going to return, at least in the next video, and just think about friction, specifically when these two objects are in contact with the edge. How might they realistically slow down as if there's a contact friction between those objects and the surface or the edge of the canvas itself? All right. I think, unfortunately, Well, that's good. I got through 2 additional video tutorials today. I mean, I'm going to get to spring forces. Don't worry. All is coming. Do I have time to do the friction? I don't really. I kind of want to. I could eke out an extra 10 minutes. Let's see. Part of me, you know what? I should spin the wheel for the cabana. And by the way, Durkarol is asking, bigger should go high after bounce, shouldn't it? So there's lots of things that it should do that are inaccurate here for a variety of reasons, one of which is just the Euler integration technique of the sort of large time steps. But yeah, maybe there's some ways to revisit that to make it feel more accurate. Okay. Okay. Let me just at least look here. Let me look at the example. I think I'm going to stop for today and come back to friction in the next time I'm here. But I just want to look at this example. Yeah, so this is where I did it, and only if it contacts edge. Just curious to see how I did it in. Yeah, that's interesting. I mean, could probably eke this out right now. All right, everyone. I'm going to be sensible, and I'm going to stop here. But this is nice because I do have 10 more minutes, so I could answer some questions and possibly spin the wheel. So I don't know if at some point if there is still a particular. Let's go to. The funny thing is, I just want to do the marching squares as the next coding in the cabana video. So I want to spin the wheel, and then if it doesn't land on marching squares, I'm going to complain. I think it's fine for me to do marching squares. Let's go back to that to-do list and just sort of see what's there. And I'll answer some questions. I'm going to keep an eye on the chat. To-do list. Oops. Sorry. So these are topics that I could do in the cabana. Xavier is asking, what is your roadmap concerning forces videos? So pretty much, if you follow along, I know what I'm going to show. Actually, I'm going to take 10 minutes to show this because this will be good. And Alka, I know if you're still watching, I meant to get in touch with you because about the build system for Nature of Code, because I know your messages maybe expressed an interest in working on that, which so be glad to be in touch about that. But the roadmap is really following along this book table of contents. I'm making some tweaks and changes to it based on rewrites of the book. And ultimately, this is what I want to look at. But if what's coming after here is then chapter 3, where it deals with oscillation. And so there'll be a pendulum. People had asked, and springs ultimately once I get to chapter 3. So this is where I'm going here. Alka is still watching. Okay, good. So what I want to do actually in the last 10 minutes is I want to show people how how you can, on your own, get the latest version of the Nature of Code book that's in progress. Because I'm not really publishing it anywhere. I'm sharing some PDFs in the Discord with the supporter group. But you could actually just build it yourself. And so let's go into documents here. Let's make a directory called Nature of Code. And what I'm going to do requires you having Node, basically just Node installed in your computer. And so if I go to the book GitHub repo, this is the repository that has all of the content of the book. So the book is written in HTML, and I'm currently editing chapter 4. And I've gotten through a round of edits on these chapters, and then there are a lot of issues that I still need to address that are being tracked here. This is an open source project. I welcome contributions to it. I would like to hire some people to actually have some accountability and a schedule for working on this. So that's something that I'm figuring out. But what I want to look at is, if you want, let's just see. I definitely have this working on my sort of main computer. But let's just see if this, so assuming you have Node installed, first thing I should do is clone this repo. Let's do that. Oh, shoot. I messed something up in terms of my permissions. So I'm just going to clone it using HTTPS. So I'm cloning this repo, which is another fancy term for downloading the entire repo. We can see there it is. And by the way, if you're wondering about this sudden move to terminal, iTerm and all this stuff, if you go to thecodingdrain.com under More, under Workflow, this is at least the latest set of videos that kind of have about the different tools I'm using, like Git and Node and all this other stuff. These are to some extent a little bit out of date, but they're as recent as I've got. I should make a Workflow 2020 video at some point if I have time. OK, so now I'm going to keep with following these instructions. I'm going to install the global, the node module magic book globally. See if this works as a. Carlos, behind said Carlos, Luis is saying, tried to compile it, but there was some error with images to the PDF. So let's see if I encounter that error. So the Magic Book module installed successfully. By the way, you'll notice that it installed Prince.xml. So Prince.xml is the engine, I've referenced it before. It's the engine that does the actual PDF rendering. So it does the PDF rendering, and there's some limitations and some caveats with that, but let's just keep going. So now I need to also install all the other dependencies for the Nature of Code book itself. So I'm going to run npm install. That should be good. And then I'm going to look at the code as it stands, because what's really important here is this magicbook.json file, which includes a lot of the configuration for the build process. So right now it's building the entire book because it's building everything that's in files. But if I wanted to just build, and I'm going to do this right now actually, if I wanted to just, for example, just build the forces chapter, I could do this. So I'm going to just hard code, I'm going to just change this to just the force, because it'll run much faster. So I'm going to do that, and you see it's doing a PDF build with some print settings. The layout is in this file, there's CSS in this file, then the images are here. So this, if there's something wrong with this path, that's what the viewer might be referring to. And fonts, and then this is for the HTML build, which probably needs the most amount of attention and work. So now I'm going to say, I think if I just say magic book build, it should do it now. So I'm having a problem. Why is this happening to me? It's happening to me on a lot of different computers I'm using, where it's not finding the global modules. It probably has to do with my I'm using ZSH as my shell, And I have a feeling that the path is messed up. Yeah. Why? I need to add, let me just see something here. Where's the other, I guess it's gone, but add, hold on, fix global node permissions. This is the web page that I always look at. And yeah, I need this, I think. I think this has to be in my ZSHRC file. That should have happened automatically, but for whatever reason it didn't. So if I now say, whoops. I should be able to say magic book build now. Yep, okay, so that fixed that. So now it's building the book, and it finished. So now if I go and look at this, in build, there should be two folders, build 1, which is the PDF, and you can see there it is. So now I have the new, and the reason why this P is up here, because I don't have the paid Prince license on this computer that I'm using, but to actually create the book, I do have a purchased version of Prince, so which unlocks other possibilities, and you can see the book, here it is. There's some issues probably, maybe some layout weirdness, and this is one of the things that I need to work more on is how the math notation is being rendered and other sort of things. I mean, I would love a designer to just jump in and redesign this with CSS and all of that. But you can see now I've built the book. Let's go back to see if the full thing builds. So if I go back to magicbook.json, and if I change this to star.html, let's try building the whole thing again. This is going to take much longer. HTML book finished. And by the way, so the HTML build, the goal for this, and it's not there, it's not anywhere close to there, is that basically what it builds would then just drop in right here. So I would run the build process and then push it to the website and the new version of the book. But I don't have that working. This is still the same, ultimately, essentially with some tiny little changes, the same exact text from 2012. So the ultimate goal for this project is for me to do all the rewrites as well as have the build process working to build the PDF version of the book with a nice, clean, fixed up design, and the web version of the book with a nice, clean, fixed up design, and that the web version of the book would ultimately also include, and some of this is in progress, these should be, I think a lot of this was actually done. I have to go back and revisit everything, but the newer web version these would be embeds of the P5 web editor, so you could get right to the P5 web editor from any of these examples running. So if you have experience with web development, Node in particular, HTML and CSS, PDF rendering, there's a lot of weird things, book design, all of the above, and any combination of some of these skills, and you have time in your schedule to allocate to this project, right now I would say join the Discord, and maybe at some point I will post a Google form there where people could, if there's enough interest, people could fill out their information there, and I would have some kind of process to pick a couple people to work on this. But this is also an open source project, so anybody can jump in. But if you're going to try to fix some of this stuff or work on it, I would say please file a GitHub issue just to let me know, so there's not a lot of duplication of work. And yeah, so yeah, Anag is saying, what about that game that Mike Boyd built that you wanted to recreate? There's so many things that I mentioned that I intend and want to do that I don't get to. So that would be a great thing for me to revisit, etc. Okay. All right. So, I think I'm at the end now. It's noon o'clock. I'll take a couple more questions. Stay tuned. There's so many edited videos that are like in process. There's just going to be like a couple days where like a zillion new videos come out on the coding train, but they'll all be just out of these live streams. So if you're watching the live stream, it maybe won't matter to you so much. So I'm here to answer a few questions if they pop up in the chat. Projectile motion. That's a great idea. That's one of the exercises in coding train. It's an Apple Watch. It's an Apple Watch. What's one of the exercises in coding train? So maybe that would be a good. Maybe the challenges, the exercises I could do as like coding challenge videos. It's an interesting idea. Thank you all so much for joining me with this sort of stuff that I'm doing, for giving me feedback, for learning and creating stuff, for teaching this stuff to other people, all the things that the community does, and I really appreciate and enjoy. Next live stream will be a week. I was going to say a week from today, but assuming all goes according to plan, stay tuned for a guest appearance on the Coding Garden, just Coding Garden, next Wednesday, morning time, Eastern time, February 26th. Thank you, John, for your nice feedback. 6 o'clock in France. No need to salute. No, just a friendly like, hello, is good enough for me. Also, you can revisit vector fields. It's part of the nature of code. It comes up in autonomous agents. So to the extent that I can get through all the material, vector fields is on the list for sure. Thank you to Brilliant, the sponsor of the Coding Train. You can check out Brilliant at brilliant.org/coding train. There's a fun daily challenge from today. All that stuff. It's coming soon. New emojis. Coding Train, join the Discord. I've got people watching still. Join the Discord. Somebody please Choo-choo? Yeah, Choo-choo. Join the Discord. Somebody who's watching, could you please post the link to the Discord in the chat? In addition, I don't mean this as I really, from my heart, am telling you about this in case this is something you would enjoy in your life. Everything will be fine whether people buy this stuff or not. But especially like the Coding Train notebooks are really nice, and I used one if you want in the recent Coding in the Cabana video. So there is this new store that I should mention. I actually have not seen one of these pins in real life. So if anybody has ordered or has one of these pins, please take a photo of it if you're wearing it or wherever you have it and share that with me. I would love to see that. And I have a personal vested interest in these hoodies getting made, but they'll only get made if there's enough pre-orders. So if that's something that might interest you, it's just a little like push for me to get your Coding Train hoodie. So I'll mention that, and the Discord. Those are things that I wanted to mention as well. Sergio asks a great question. Is Discord only for Patreon? So this is new. The Discord is a public Discord that anybody can join. There is a code of conduct that I ask you to read and adhere to those policies. And if you have questions about that, you can reach out to me. Also, Sai, who is the Coding Train community manager, sai@thecodingtrain.com. There are some channels for supporters of the Coding Train through YouTube memberships and Patreon stuff, but the help channels and other channels are all publicly available to anyone. So that's kind of like where I suggest asking your coding questions, or if they're processing or P5 specific, you can also use the processing forum. Thanks, everybody. I will play you out with a bunch of the Coding Train remixes. I'm going to see if I can get one of the new ones going that I didn't know, because I can rewire some stuff and play from SoundCloud directly. So stay tuned for some of those other Coding Train remixes that I will play as the outro sequence plays. Thank you, everybody. Mwah! You are all wonderful. Goodbye. Choo choo.
As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget the this dot, this dot, this dot, this dot, this dot song. This dot, this dot. This dot, never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. Firework is not defined in line 6.
Little known
as
fact.
always, I always forget the this.
There is a second This Dot song that was created by F. Looper, who created the Perlin Noise song. So here, I rarely play this, but I'm going to play it right now. This is another version of the This Dot song. Different tune, totally different. I haven't listened to this in a while.
Dot, this dot, this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. Okay. This dot, this dot, this dot, the this dot song. Never forget the this dot. This dot, this dot, this dot, the this dot, this dot, this dot, the this dot, this dot, this dot, the this dot song. Never forget the this dot. This dot, this dot, this dot, this dot song. This dot, this dot, this dot, the this dot song. Never forget the this dot. This dot, this dot, this dot, the this dot, this dot, this dot, the this dot, this dot, this dot, the this dot song. Never forget the this dot. This dot, this dot, this dot, this dot song. Firework is not defined. Okay, line 6. As always, I always forget the this dot, this dot, this dot, this dot song. Firework is not defined. Okay, line 6. As always, I always forget the this dot, this dot, this dot, this dot song. Firework is not defined. Okay, line 6. As always, I always forget the this dot, this dot, this dot, this dot song. Firework is not defined. Okay, line 6. As always, I always forget the this dot, this dot, this dot, this dot song. Firework is not defined in line 6. Yep. As always, I always forget the this dot, this dot, this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. Okay. Firework is not defined. This dot, this dot, this dot, the this dot song. Never forget this dot. This dot, this dot, this dot, the this dot, this dot, this dot, the this dot, this dot, this dot, the this dot song. Never forget this dot. This dot, this dot, this dot, this dot song. This dot, this dot, this dot, the this dot song. Never forget this dot. This dot, this dot, this dot, the this dot, this dot, this dot, the this dot, this dot, this dot, the this dot song. Never forget this dot. This dot, this dot. Unicorns and rainbows and cupcakes. What else is there?
This dot neighbor. The unicorn song is the one I usually like to do at the end. So here's flood fill time. It's flood fill time. It's flood fill time. It's flood fill time. It's flood fill time. I'm not going to look it up how it works. I'm just going to make up my own way of doing this. This dot. Flood fill from Wikipedia. Also called fill is an algorithm that determines the area connected to a given node. No, you reveal yourself. No, you reveal yourself. You reveal yourself. You reveal yourself. Everybody reveal themselves. Then we've got a problem. So now what I need to do is I need to go and look at all of the different things. It's flood fill time. 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 Different things. Okay. Now we've got the loading
I
song.
could do better, but anyway, there was an error. The song didn't load. And then there's a callback that's like, it's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. So let's see if this works now. It's loading, it's loading, it's the loading song. 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 It's loading, 1, 2, 3, 4, 5, 6, 7, 8, 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, 1, 2, 3, 4, 5, 6, 7, 8. 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song.
So what I was really expecting to happen is for those not to come in order. They did come in order, which is kind of lucky, but there's no way to guarantee that they're going to happen in order.
So that's how to program a loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. 0 to 1, 2 to 3, 4, 5, 6, 7, 8, 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading.
Oh, I need a soundboard really badly.
The loading song. Of course, I could do sound synthesis myself. And then listen. Triangle to twirl. Oscillator. One full cycle that just repeats over and over again. All aboard! Hello, I'm here. I am here mostly to apologize. Please stop, don't throw the tomatoes. They're the green wall will have tomato splats on them. But I'm here just to give a quick update about my machine learning videos. That I have a playlist called 10 Neural Networks - the Nature of Code. I was making these videos over the summer. Then I had this moment where I was like riding along on a bicycle and I was thinking way too much about machine learning. I had a bump, fell over, I broke my elbow, I had surgery on it twice. I lost a couple months of like being able to make content, and then the fall started. So unfortunately, I was in the middle of this series. I was at 10.7. I had made 7 videos, that's crazy. And every time I upload a video now, I get a lot of comments asking, could I please continue that series? And I am planning to continue it. What I do here on the coding train is I make videos about stuff that I'm currently teaching at my full-time job here at New York University. And currently what I'm teaching is an introduction to programming course and a course about text analysis. So I am going to be making some videos about chatbots, which is kind of adjacent to, and machine learning can be a tool to drive a chatbot. I'm also going to make some videos about, hopefully long-term, short-term, I can't remember. I don't have long or short-term memory, but some of these recurrent neural networks for text generation. And then my hope is that I will be coming back to this playlist again after this semester is over, or towards the end of the semester if I've finished up some of the content. So in the meantime, I hope to continue to have some GitHub repositories where I'm going to be making some new examples, so stay in touch with me on Twitter. And I would recommend to you, as you've seen as a guest on my channel, Suraj has a channel about deep learning. And also, this is a new video that just came out from one of my favorite channels, 3 Blue, 1 Brown. But what is a neural network? Deep Learning Part 1. So now we have an internet competition. Will Deep Learning Part 2 come out before 10.8? The answer is almost a definite yes. So please write all of your complaints in the comments here. I'm going to read them. I'm going to sit with some sort of like meditative cucumber eye mask thing on, and I'm going to listen to all of your feedback about why I should do this right now instead of the other stuff that
this short little video explanation, and I'll see you soon.
Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens. 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 I feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Dream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax. I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. First thing I need to do is, yes, kittens. Kittens, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and До свидания.
If this.neighbor count